What is the largest star in the universe? And why is it that large? And what are stars anyway? Things that would like to be stars. We begin our journey with Earth, not to learn anything, just to get a vague sense of scale. The smallest things that have some star-like properties are large gas giants or sub-brown dwarfs, like Jupiter, the most massive planet in the solar system, 11 times larger and 317 times more massive than Earth, and more or less made of the same stuff as our Sun, just much less of it. The transition towards stars begins with brown dwarfs, failed stars that are a huge disappointment to their mums. They have between 13 and 90 times the mass of Jupiter. So even if we took 90 Jupiters and threw them at each other, although fun to watch, it wouldn't be enough to create a star. Interestingly, adding lots of mass to a brown dwarf doesn't make it much bigger, just its insides denser. The brightest star in the night sky, Sirius, is 2 solar masses with a radius 1.7 times that of the Sun, but its surface is nearly 10,000 degrees Celsius, making it shine 25 times brighter. Burning that hot reduces its total lifespan by 4 times to 2.5 billion years. Stars close to 10 times the mass of our Sun have surface temperatures near 25,000 degrees Celsius. Beta Centauri contains 2 of these massive stars, each shining with about 20,000 times the power of the Sun. That's a lot of power coming from something only 13 times larger, but they'll only burn for about 20 million years. Entire generations of these blue stars die in the time it takes the Sun to orbit the galaxy once. So is this the formula? The more massive, the larger the star? The most massive star that we know is R136a1. It has 315 solar masses and is nearly 9 million times brighter than the Sun. And yet, despite its tremendous mass and power, it's barely 30 times the size of the Sun. The star is so extreme and barely held together by gravity that it loses 321,000 billion tons of material through its stellar wind every single second. When main sequence stars begin to exhaust the hydrogen in their core, it contracts, making it hotter and denser. This leads to hotter and faster fusion, which pushes back against gravity and makes the outer layers swell in a giant phase. And these stars become truly giant indeed.